Alright, so I've decided to try to use Cam Studio again to record, and this time to record my working of a problem. Uh, the screen you see before you is actually the complete working of parts A, B, and D. I had done it a piece at a time before, but that only came out well in a shockwave file, and I think AVI is what you're going to want better. So I'm going to use the cursor here as a pencil and try to tell you what's going on. So these were the numbers that I was given for my part as a pseudo student in the class, and you can see that this one right here is the one that gets changed between the various students who do this. I have as my y component of the vector capital letter R minus 3.67. 2.10 is the x component and 1.00 is the z component. Now in Physics 222 we're not going to worry about significant figures. We're going to assume everything has as many digits as I want it to be, so you can report up to 8 or 9 significant digits as though they were significant. So when we calculate the magnitude of a vector, that's this part A right here, we first of all need to know some notation. So I used bold-faced R as the vector sign without the arrow above it, and I put the two arrow or straight lines on either side to indicate absolute value. That can also be written as R that is not bold-faced. In any case, you use Pythagorean theorem to find out how long the vector is, and it will be then the square root of the sum of three numbers squared, and those three numbers are the x, y, and z components of the vector. So there they are, 2.1 squared minus 3.67 squared and 1 squared. When you sum all those up, you get 18.88 approximately, and when you take its square root, you get 4.345, and I've tried that out. This is in fact a correct answer. Okay. Now to get the z component of the unit vector r, we have to remember what a unit vector is. And a unit vector is the vector r that we had right here divided by its magnitude. So that will guarantee that it has a length of exactly 1. So vector r has three components. There they are. And we're going to take and divide each of those components by the length of the vector 4.345 that I established earlier. And then that by doing that simple calculation we get 0.2302, and if we check it out online, I did all of these and then checked them out, we got the right answer. Okay, to do a cross product is a little trickier. I do my evaluation of cross products using a matrix trick or a determinant trick. I put the components I, j, and k in the first row of the matrix, and you see them here. There I put the hat on each one of them, and then I put in the second row of the matrix, the middle row, the first vector r. So all of its components go in here. The x component goes below I, the y component goes below j, and the z component goes below k. And similarly, I put the s vector, its components, below those, 3.3, 4, and 0.9. Now, the trick I know for multiplying out vectors is called an augmented vector approach, and so or an augmented determinant approach. So you can put along either the top or the bottom, I choose the top, the vector components by rotation. So next to I, we would have k, and over here on the left side, if we needed it, we could put I in over here. And we could similarly put values down here below if we needed them. by rotation. So this one down here on the left side would be 0.9. And next to it, of course, is our 3.3. Well, it turns out that the way the matrix is set up, we don't have to do much augmentation. The positive values are determined by coming down like this along the diagonal from upper left to lower right, and that gives us as plus 2.1 times 4, and then we subtract from it the components starting from the lower left side and going to the upper right side, and those are right here 3.3 minus 3.67. When we do the math on that, we get that the length of that vector that we're calculating is going to have in the k direction 20.5 units. And I put that into the computer and it also works out. The computer tells me I did it just fine. Alright, so at this point I'm going to turn off the recording and see how well we did.